A projectile is an object that is launched, or thrown, and then moves freely through the air. A projectile experiences two types of motion, horizontal and vertical. Horizontal motion of projectile is constant, that means horizontal speed of projectile does not change. Vertical motion of projectile is not constant, that means vertical speed changes as it moves, and horizontal and vertical motion of projectile is independent of each other. The path of projectile is parabola. A projectile is fired with an elevation alpha, an initial velocity v0. Find horizontal distance and alpha for maximum range.
Upon the launch of the projectile, the sole influence is the gravitational force, operating in a downward trajectory, specifically, the negative j direction. This force is a product of mass and acceleration, denoted by A, where A represents the acceleration attributed to gravity, with a standardized value of 9.8 meters per second squared. The acceleration emerges as the derivative of velocity, and upon integration, the result is the velocity. So, the velocity is negative gt in the j direction, alongside a constant term representing the initial velocity. If we integrate once more, we arrive at the formula for position. At time t, it equals negative g square, where g is acceleration due to gravity, and added to t times the starting velocity, and then further adjusted by a constant. This constant is 0 as the projectile begins from its initial position. We can break down the velocity into two parts, one that goes horizontally, v0 cosine alpha, and one that goes vertically, v0 sine alpha. When we compare this with the previous equation, we can find the position formula as follows. In this formula, x represents how far the projectile goes horizontally, v0 cosine alpha times t, and y shows the vertical distance it covers, v0 sine alpha times t minus half times g times t squared, where g is a constant due to gravity. The horizontal distance d is the value of x when y is 0. When we set y to be equal to 0, we find that there are two moments when this happens: at the start, when time t is 0, and at a time of 2 v0 sine alpha by g. The distance d reaches its maximum value when the launch angle is set at 45 degrees.